What's going on, guys? Your everyday math tutor here. And in this lesson, we're going to be going over expanding expressions. And we're going to be using primarily the distributive properties. So let's start off with a very easy one. This is the first one. We'll have 3 times t minus 2. And my apologies if you hear airplanes in the background, but I live literally nearby an airport, within 3 miles of an airport, so there's always something taking off and there's always something coming into land. But anyways, all right, so actually what I'm gonna do is close the window. But anyways, let's go ahead and begin this math problem. So the first thing we're gonna do is use the distributive property, and what that tells us is that we can multiply the 3 to everything, to every term that's inside the parentheses. So the first thing we're going to do is I'm just going to write the multiplication down. So the first thing we did was 3 times t, and now we're going to do 3 times negative 2. So what I like to do is add it, and then 3 times negative 2. And of course, just a number times a variable would just be its 3t here. And then we're going to have plus 3 times negative 2, which is negative 6. And it's weird because I did close the window and it sounds like there's still sound coming through. Alright, so then the last part we're going to do is this t, or this plus and minus sign. What that tells us that there's a positive number times a negative number. Anytime we see different signs together, we're going to always go with the negative sign. So we go 3t minus 6. And this is the expanded form here. Now let's do a little bit of a more challenging one, perhaps, maybe not. Actually, yes, let's do 2 times y plus 5x. All right, well, the same thing. We're going to use the distributive property. What that says is that we multiply the 2 to every term inside the parentheses. So 2 times y, I'm going to go ahead and just write that down. 2 times y plus 2 times 5x. So that is 2 times 5x here. And now we just simply multiply 2 times y over here on the left side. That's just going to be 2y plus 2 times 5x. We're doing this now. And we're just multiplying the coefficient here by, or at least in this part, we're just multiplying the number times the coefficient and bringing back that x. So 2 times 5 is 10. Bring back that x, it's 10x. Nothing else we can do here, and that is the expanded form here, at least for this problem. Now let's do a bit of, so let's introduce some fractions here. And by the way, I'm just doing this on the run. I didn't really go over these problems. These are problems I'm looking at a screen right now. So we have problem number 2. So let's underline this with a line here so we know we can move on to different problems. We get confused with the work we have here. So we have negative half times y minus x. Again, this is just going to be multiplying the negative half to every term inside. And we're going to get negative half times y. And then plus, I'm going to write plus because what I want you guys to see is that this negative half is being multiplied by a negative x. And a lot of people are like, well, it's not two negative numbers being multiplied. Well, it is because we have a negative half. Everything that has a negative is always basically being multiplied by negative 1. In this case, we only have one x and a negative. So when we have a negative and a negative, well, the multiplication rule says that that must be a positive. So that's why I like to kind of write this down for my students this way, is because it shows that there'll be two, it's better when it comes down to the multiplication that you could see it more clearly that there will be two negatives being multiplied here. So we have the negative half y over here on the left side, and because both negatives will essentially cancel out, we are left with just plus half x. And a lot of people, a lot of students, they will get confused and actually add these, or at least maybe subtract because of the negative, but you can't add these because they're not like terms. They don't have the same variable. So this is the final answer for this problem here. All right, so now we can move on to our final problem here, at least for this examples, or these examples. Let's have, I'm going to choose, okay, so we'll choose this one here. We have a parentheses 8 plus 2b minus 6. Okay, so let me just kind of make this a little more clear. Okay, so yes, we can use the distributive property here. Yes, we can multiply the a to the 8, the a to the 2b, and the a to the -6. So we have three things here we can multiply by. But sometimes it's good enough to ask yourself whether there are like terms inside the parentheses first. And in this case, there is two terms that are like terms. We have just one variable. We don't have another variable, so there isn't any like terms. And then we have the 8 and the -6. Those are like terms because those are just numbers. So what we could do is add those numbers together, or at least subtract them here in this example. Because the 8 is positive and the 6 is negative, we can do 8 minus 6, and that would just give us 2. So we are left with 8, or a rather, 2 plus 2b, because 8 minus 6 is just 2. And then because there's no other variable, we can just drop down the 2b. And because it was positive, we also bring back the positive here for that term. And now we can use the distributive property. Now we can multiply the a to the 2 and the a to the 2b. So a times 2 plus a times 2b. Now, of course, once you become familiar with the distributive property, you don't have to always write what you're actually multiplying. It's just for students who may sometimes get confused with multiplying different signs. It's a little bit more clear to see. But anyways, a times 2 is just going to be 2a. We always write its coefficient first. And then a times 2b, well, what happens here is you write your coefficient first, and you're left with a times b. What is a times b? Well, that's just simply ab. Okay? Just for example, you can have 4 times 3. Let's just say that this was our a and b. Well, 4 times 3 is 12. Well, so is b times a, or at least 3 times 4 now, which is still 12. This was just an example, by the way. Multiplication, it doesn't matter. A times b is the same as b times a. So those are 4 examples. I'll be posting more in the coming hours, maybe coming days. But if you enjoyed this video and you found it insightful, please give this video a like, and I'll see you guys in the next one.